All right, so the second part of the lecture for this week looks a little different, um, but we're still continuing on with the themes for this week. The first section we looked at variables, and now we're looking at the relationships between variables. This is an intro into what we'll talk about in a little bit more depth in a couple weeks, thinking about correlation and the kind of the ways that we predict reality using statistics. But we'll leave that for another day. Today we're just focusing on the relationships between variables. So we talked about different kinds of variables in the last video. In this video, we're going to talk about the ways that they can be related. And we'll talk about each of the ways listed on this slide in turn. So a positive linear relationship means means that one variable is increasing, the other is also increasing. One variable is decreasing, the other is also decreasing. So they're going together in the same direction. A negative linear relationship is one variable is going up or increasing, the other one is decreasing. So this is one goes up, the other goes down. The difference here that I want you guys to be really careful with is that sometimes it can be a good thing, a positive for the world and for our participants finding to have a negative linear relationship. So don't get caught up too much with the way that we term those, right? So positive is that they're increasing or decreasing together. Negative is as one increases, the other one decreases, right? So and these aren't talking about the value of the relationship so much as the direction of the relationship. We also sometimes have curvilinear relationships. The main thing to remember here for the curvilinear relationships is that they are different in terms of assessment. And we'll talk about that more in a couple slides. The curvilinear relationship means that at a certain level of a variable, there's an increase, and then at another level, it is decreasing. So it's if you imagine a graph, it's kind of like a curve, right? That's easier to see when I can show you the graph in a couple slides. It is also possible for there to be no relationship between variables. And the point of looking for relationships between variables in the first place, trying to categorize it in these ways, is because it helps us to eliminate or kind of minimize the uncertainty in our research, right? So how are these different things related? Again, a relationship is not between variables is not the same as cause, right? Just because there's a relationship doesn't mean that there's cause, mostly because of that third requirement of cause, as we talked about last week, which is that all of the possible explanations for a relationship have to be excluded, right? We need to exclude all other explanations for the effect. So, but knowing what kinds of relationships exist help us to minimize the uncertainty. Okay. So here's a graph that helps a little bit. So if you see in graph A, top and to your left there, as one variable is decreased, the other one is decreased. As one is increased, the other one is increased. So they're increasing together, decreasing together. That is a positive relationship, positive linear relationship. Graph B is a negative linear relationship. As one is low, the other one's high, right? This is showing a hypothetical, but it's actually a relationship that exists in social psychology, that if you get a large group of people in a small space, the more people that are there, the quieter they will be. So we tend to quiet down when we're in an enclosed space with a lot of folks. If there's a few folks in an enclosed space, we are louder. Graph C down there is a curvilinear relationship. This is also an observed relationship in cognitive psych, where the complexity of a stimulus is related to how much we like it, We don't like really, really simple things, and we don't like too complex things. I'll show you an example of this in a second. The last graph D, again, be careful with this here, because it looks like a line, it looks like a linear relationship. This is actually indicating that there is no relationship here in graph D. So again, the relationship between attitude change and speech rate. Did you know that if I speak really fast, you are likely to agree with me more? So if I can talk really fast, don't give you a chance to judge or assess what I'm saying as I'm saying it, you are more likely to agree with me, right? I am more likely to be able to change your attitude about something, more convincing. Sales folks may talk very fast, try to get you to get emotionally engaged or committed otherwise to a decision before you have a chance to second guess it. An example of that amount of noise and group size, we can see that on public transit or in crowded elevators. We haven't seen a whole lot of this recently because of the COVID, but we can see this in a lot of public spaces where folks are in large groups with strangers, that they will be quieter. For graph C, I'm using an example from my stepfather's art. So he sells images on greeting cards, and there you can see that there's been a little bit of modeling or changes done, editing done to the pictures on the screen of that white flower. The one on the lowest part of the screen is the original. That is the original image. The top is black and white, so there's less contrast, less kind of complexity to black and white because they're taking out the color out of it. The original stimulus has a whole bunch of background, right? You can see the flower is in focus, but there's also some other stuff going on behind it. He has found in selling his pictures that people tend to like the flowers where there is a moderate amount of complexity, so the black and whites don't sell as well as things with color most of the time, depending on how complex the black and white image is. But also he's found that if he can completely erase or black out the background, as he has in the bigger middle picture here, that is related to a better sales. So people tend to like that better. These are also different ways of depicting no relationship between variables. One is a linear and the other are just scatter plots. Okay, so we're gonna switch or skip past this because most of you don't have variables figured out for your first study yet. We'll be working on that in the next couple weeks, but looking at different ways of testing those variables. There is non-experimental versus experimental methods. The non-experimental, we would not be able to look at the difference between, or the relationship between cause and effect. What we're going to be looking at in terms of a content analysis for our first study, looking at what is out there. Are there differences in the ways we depict things for kids? Are there different amounts of genders? Do the boys say more directive things and girls say more questions? These are some of the kinds of things you can look at in a content analysis of children's media, which is what we'll be doing for our first project. None of this is suggesting anything about cause and effect. This is all a descriptive, right? What is out there? We're just going to talk about what is out there. We can talk about differences in terms of what is out there, but we can't really talk about cause. So this is not an experiment. So in a non-experimental study, like what we're going to be doing, because we can't look at cause, that we don't know the directionality of the relationship. So one of these examples is there's a relationship between exercise and anxiety. So higher rates of exercise, lower rates of anxiety? So does this lack of exercise cause anxiety, or does having anxiety mean that you are exercising more, right? And it could be that there is a third variable that is impeding all of this. That third variable is affecting both exercise and anxiety. So often people have found that those who have greater anxiety and those who are exercising more are within a certain income bracket, so they have access to being able to exercise more frequently, and they are working jobs that make them more anxious. So some versions of non-experimental methods are naturalistic observations, correlations, description. This is a lot of what we're going to be doing in both of our studies and for this class. Experimental method, part of why we're not doing it for this class, for our studies, is because it requires a lot of control. So being able to randomize the presentation of different conditions, so making sure that everyone is just as likely to get the control condition as they are to get the experimental condition, that we have everything controlled. So only the thing that we think is causing a relationship is varied. Everything else is controlled. The quote that I have here on the screen that I wanted to present to you guys about this encapsulates some of the issues with using experimental method for talking about work with kids or research with kids. And the quote here comes from Bronfenbrenner. Some of you may know him from the ecological theory. Great guy, and really useful theory. But he says the science of behavior, that developmental psychology is the science of behavior of children with strange adults in strange situations for the shortest periods of time. So again, developmental psychology is the science of behavior of children with strange adults in strange situations for the shortest period of time. That's quite a critique, right? So what he's saying there is that part of when we control everything in our using experimental method, we want to make sure that there are no differences in how the parents are interacting with the kids. We want to make sure that all of the kids have the same amount of toys. We want to make sure that each of the kids has been fed the exact same thing in the same amount of time before the study, right? In his argument is that in controlling that, we end up putting kids in really strange situations that may not be like real life, right? And this is kind of the give and take. You get to say about cause because you're controlling everything, but you're also not able to, it impedes your ability to talk about reality, right? Because you've made a situation where everything is so controlled that it's not necessarily that realistic. So some other ways of looking at dependent and independent variables, different ways of talking about the relationships between variables. So when we're looking at a study to try to figure out if one affects the other, the dependent variable is going to be the outcome, right? That's where we're looking for the change. The independent variable is the thing that changes, that might create a change or something that we can document in the dependent variable. So I like that this little the little cartoon here helps me remember. So the independent variable says, nothing you do affects me, I'm independent. And the other guy, the dependent variable, said, some things you do affect me. So not everything, but some things you do affect me. Again, talking about cause and noting that there are three things that we have to have in order to call something say that something is causing something else. One, the cause has to precede the effect. Two, they have to go together. We have to see them co-vary. When one exists, the other one exists. They come together. And we have to eliminate all other potential explanations for the relationship, right? Okay. The other thing that I wanted to present is that we have advantages when we use multiple methods. So if we have um, lots of different ways of looking at the same question, we're more likely to get a usable and more kind of elucidative answer, something that tells us more. So experiments are good, but because, as Bronfenbrenner said, we control the heck out of everything, so it's not so realistic, right? Because of that, we also may need some naturalistic stuff. There's often cases where experiments and controlling everything may not work, right? So you have kids that are developing anxiety and depression issues. Well, is it because they were treated poorly when they were in their first couple years of life? They didn't have such good attachment? Maybe. Well, if we wanted to do an experiment and really see for sure what the cause was, right? In order to control everything, we'd have to bring up babies in exactly the same situations, except for some of them would get mistreated in the first couple of years of life and some of them would not. Well, that is never going to be okay, right? There's no way to do that ethically. So there are some questions that we can't do experiments on, right? The other thing about variables that we've talked about is that participant variables you can't change. As much as I might like to, I cannot be a black man. And there's problems I acknowledge with saying that that I would want to be, but I can't change my gender. I can't change my race. Um, I can't change my sexuality. This is who I am, right? You can ask people to imagine being, but there's problems there, right? So I can't, there are some things I can't do an experimental study on because I can't know what would my life be like as as a man, because because my whole life has been conducted and been shaped by my gender since uh, the beginning. We can get at predictions of behavior without actually understanding causes. So we can get most of the way there, still not looking at causes. But the idea here is that if we can use lots of different ways of getting at the same question or understanding the same phenomena, then we're doing better than if we just use one experiment or one way of coming at a question. We're going to stop there and we'll come back to talk about validity and reliability.